Now, what I want you to do, in fact, I'll help you with this a little bit. I'm going to move this over here, give us a bit more space. I'm going to break the circuit there. And I'm going to ask you now to take over and put an extra battery in. Click on the end of the wire and that's it, keep going. That's it, you're joined up now. The bulb is on. Can you see the bulb is brighter?
Yeah.
Right. I want you to get the voltmeter out and measure the voltage across the bulb. And what's the voltage across the bulb?
3.
Before it was 1.5. And when it was 1.5, it was only so bright. It was fairly dim, actually. And now I've got 3 volts across it. So by putting...
Oh, that means if we had one more, it'd be 4.
Why don't we try it? So why don't you take the voltmeter away, drag the voltmeter back onto its stocking bay on the right-hand side, drag it back over there, out of the way.
That means it's going to be 450.
It should be 450. Oh, 4.5. You've got to be connected there. You're not connected yet. The black one's not connected up yet. That's it, 4.5, okay? You can drag the voltmeter itself, the actual device, down below the screen to see what you're doing. There we go. So it's 4.5. So that's what you should predict, yes? If you put more batteries in, every time you add 1.5, you've had more push. There's more push in the circuit. And because there's more push in the circuit, there's going to be more energy in the electrons, and there's going to be more brightness on the bulb. And we can see the bulb has gone from 1.5 volts to 3 volts to 4.5 volts. So all that push has ended up pushing charges, more charges with more energy through the bulb, and the bulb is brighter. Now, I don't know whether you've noticed it, but the charges have been going slightly faster. I don't know if you look at the, have you looked at the charges flowing around the circuit? Why don't we take out one of the cells and just leave 2 cells in the circuit and look at the flow rate of the charges. And look, they're not moving as fast, they're moving slower. Yeah. So what actually happens, of course, is if you're not pushing them as hard, they're not going to move quite as fast. So the current in the circuit is not going to be as great. So the amount of energy being dropped off at the bulb is not going to be as much, so the bulb won't be brighter. So these charges, their only job of the charges is to carry the energy around the circuit in their motion. And because they're not going quite as fast, they're not going to deliver as much energy to the bulb as they did before. The bulb's only getting 3 volts worth of push. It was getting 4.5. It's not getting so much energy anymore. Does all this make sense?
Yeah.
So you can now draw what is in front of you. This is called a series circuit because everything is running one after the other in series, one after the other. So I'm going from the bulb, I'm going from the battery to the bulb, to the switch, round to the battery. It's all in one loop. Now, what do you think might happen if we put a second bulb in the circuit?
Yeah.
Why don't we try it? Take away the voltmeter. Yeah, you got control, so you can take it away to the right-hand side, park it in its parking bay. Right, now, you need to break the circuit where the bulb is and drag a second bulb in and connect the 2 bulbs together by a piece of wire. So grab your voltmeter on the right-hand side and drag it back on.
Wait, what?
So drag your voltmeter on the right-hand side.
Oh, right, yeah, and then...
Drag that out, and then connect it across just one of the bulbs. Yeah, good, good, good. Yeah, right. So what's happened here?
It's reduced by 1.5.
Yes. So what's actually happened, we shared the voltage out. To prove that, put it across the other bulb to see if we've got 1.5 volts across that bulb. Yes, look, 1.5 volts.
Yeah.
So literally you've shared out the voltage. You've got 3 volts on the battery and you've shared out 1.5 to the first bulb and 1.5 to the second bulb, yes?
Yeah.
Does that make sense?
Yeah.
I've got one more challenge for you before we move on to something a bit more complicated, okay? I'd like you now to make up a circuit with 3 batteries, 3 cells making up the battery, 3 of them. You've got a third one there on the top of the screen, and 3 bulbs all in series. Oh, hang on, before you do that, can you predict what you're going to get? I've got 3 cells. I've got 3 cells. That's 4.5, 1.5, 1.5, 1.5. I've got 3 bulbs, all in series. What am I going to get across each bulb?
I feel like you're not. I think you're going to get lower than 1.5.
You think so?
Actually, no, 1.5.
No, you get 1.5. It's a fair distribution. In other words, the circuit is being very fair. It's taking the 4.5 volts, 1.5 plus 1.5 plus 1.5. It's got 3 equal bulbs, and because they're in series, it's sharing out the 4.5 into dollops of 1.5 to each bulb. Doesn't matter which bulb you get.